Assalamu alaikum. Hello, everyone. We are Stars team, and today we will present our paper building automatic extractive question answering system for the Holy Quran with transformer models and releasing a new data set. This is our agenda for today. In our paper, we conducted many experiments with transformers. We created a BERT-based Quran masked language model that then using it for building the question answering model. Also, we tried ensemble of different transformers to strengthen each other for better result and achieve 52 percentage best PRR score on the test set and 62 percentage score on the development dataset, and we released a new dataset. About related work. For the related work about the Quranic datasets, Ayatik is a dataset for Arabic QA on the Holy Quran. All of the Quranic verses that directly answer the question were extracted and annotated. The answers are divided into single answer, multiple answer, and no answers with evaluation for each type. Also, there is a dataset have a partial matching for the required structure of the Quran QA task called AQQAC. AQQAC was annotated the corpus of Arabic AI Quran QA using machine learning. And for the Arabic QA systems, the first system evaluated the performance of three existing Arabic pre-trained models on Arabic QA. Al-Bayan proposed a novel question answering system for the Quran that extracted the answer from the retrieved verses combined by their tafsir. Last one, Neural Arabic Question Answering proposed an approach for open domain Arabic QA and introduced the Arabic Reading Comprehension Dataset, ERCD, and Arabic Squad. About the dataset, there are the dataset we use for the Quran QA. First one, the mean and the official dataset we used, it helps us force understanding the task and creating a similar dataset following the same structure. After searching for any open source dataset that can work fine for Quran QA, the only related dataset was found is the AI Quran question and answer compilation, AQQAC. It's a collection of 1,224 question and answer regarding the AI Quran, combining more dataset that can increase the dataset and get higher score, but we still couldn't use it directly. About Arabic Squad. Arabic Squad is a dataset with about 48,000 questions on 10,000 paragraphs. The paragraphs are extracted from the Wikipedia article, so this dataset isn't related to Quran QA, but we aimed to make the model deal with the Arabic question answer in general. After that, we expected the model can perform better when we apply the Quran QA. With the challenges, there are the challenge we had. First one, the limited question answer for QRCD. The data is small, which has about 700 questions. Most of them are repeated questions for different passages from Quran verses. Second one, the unavailability of open source dataset related to Quran QA task. And third one, about the automated and the manual dataset. With the previous two challenges, we decided to collect our own dataset to combine it with the QRCD, and with the help of AQQAC. The first plan is to generate an automated dataset that enables us to create a large-scale dataset. Creating it manually means consuming time with generating a small-scale dataset. So the challenges with AQQAC that are the most of the answer aren't extracted from their specific passages. The passages and the answers are mixed with the Quran verses and tafsir. There are answers with the same meaning but with different words that aren't found in the Quran. And there are types of question like ما معنى كلمة ما الدليل من القرآن aren't related to Quran QA task. We couldn't solve all these issues, so we decided to do it manually by using the question of AQQAC. Last one about we need the Quran expert. Before answering any question from Quranic passage manually, that requires knowing the tafsir and the meaning of the passage with related context events. So we have in our team a Quran scholar who added the passage and the answers for every question and created some similar question. This is our data. We constructed it like the original dataset and added multiple same question with other different passages. We used it for the first and second submission with about 625 questions. We collected more to be 732 questions, and it used for the third submission. By this data, the score in the BRR increased by 10 for the development evaluation. About our methodology. There are four main components and ideas that we used for constructing our solution approaches. So we focus on the main four elements. First, about the masked language model that were the basic building blocks for our approaches. We haven't only made use of existing Arabic pre-trained like BERT, but we also created our Quranic MLM by fine-tuning Arabic on the Holy Quran verses only. The second step is pre-processing. Pre-processing where we put together the two sequences for tokenization and encoding the tokens to be used for the fine-tuning. For the fine-tuning, the MLM for our task, which is the third step. Finally, we tried using ensemble of many fine-tuned QA models and take a vote of the best answer to achieve better result. There are three approaches. For the first one, we fine-tuned our masked language model for Quran that we named the Quran BERT. We were generated from the ensemble of the many trained model. Most of them were Quran BERT-based model. Different combination of the data were used for training the weak learners. Some were trained on QRCD data only. Others were trained on QRCD augmented by our data, and other with a random portion of Arabic squad dataset. Also with variety of training configuration like ebook, batch size, learning rate, or weight decay. For the second submission, we have divided the competition dataset merged with our extracted AQ dataset, our data, into 8 folders instead of using normal bootstrapping, as we might get more dissimilar weak learners for better final ensemble model. Then, the training of 8 transformer has been accomplished with configuration pair split data. For this approach, we focused on measuring the effect of the size of data on the performance. We worked on creating more ensemble during the last moments of the competition deadlines. We reached about 732 samples. This combined with QRCD data set is to be about 1,000 and a half samples. We did the shuffle for all data and used Arabert transformer base version, and it was the third submission. About the result, there are the result of 3 different approaches on both development dataset. All 3 systems perform better than fine-tuning Arbert-based model with QRCD data, which gives about 44% in BRR on the development data set. For the test, these are the result for the three different approaches on the test set. We notice that the ensemble and Quran BERT aren't as effective as increasing the size of AQ dataset, our data, with fresh sample, which might be attributed to the following reason. We have only 1,000 and a half Quran training examples in the best case scenario, QRCD and our data, which makes the split coming out of bootstrapping to be very similar. Also, the weak learners of the ensemble will be almost identical, especially given that transformers are known to be extremely data intensive. On the other hand, most language models are known to be trained on a large corpus of the text, so about 6,000 verses on the Quran are tiny in size compared to that enormous amount of data that our bird is trained on. For example, additionally, in the question answering task model, needs to learn the attention between two different sequences of the passage, which is non-Quranic sentence, unlike the single Quranic sequence in the masked language task. Okay, for the conclusion and the future work, we propose three different approaches with remarkable result. The best and the highest one was expanding AQ, our data, with 0.528 BRR in testing. The second approach was ensembling the most three best models, and it's called key folds ensemble approach. Its BRR score was 0.521. The last one was training BERT model in Quran. Then we used this pre-trained model for this specific Qur'an QA. The BRR score of Qur'an BERT was 0.502. The scores for the three approaches are similar. For all three approaches, we developed and deployed the system with transformer models. Also, we proposed a new Arabic question answering dataset from the Holy Quran called AQ, about 732 question answers. In the future work, the data team aims to increase the AQ dataset. We plan to cover all kinds of question with answer, adding complex question and increasing the question with multiple answer. In order to improve the score of the system, we plan to expand our experiment for more approaches in different directions. Also, we plan to make the system and the AQ dataset available to the rich community. Thanks for listening, and I hope you enjoy this presentation. Thank you a lot.